So let's take a look at the laboratory project. So laboratory project, putting 3D in perspective. So I'll go over all of this, has all the questions, and then we'll go over question 1. So computer graphics programmers face the same challenges as the great painters of the past. How to represent a 3-dimensional scene as a flat image on a 2-dimensional plane, in other words, a screen or a canvas. So to create the illusion of perspective, in which closer objects appear larger than those farther away, 3-dimensional objects in the computer's memory are projected onto a rectangular screen window from a viewpoint where the eye or camera is located. The viewing volume, or the portion of space that will be visible, is the region contained in the 4 planes that pass through the viewpoint and an edge of the screen window. If objects in the scene extend beyond these 4 planes, they must be truncated before pixel data are sent to the screen. These planes are therefore called clipping planes. So basically, you have a camera like this, and then the clipping planes will be, you'll have 4 of them. Here goes to the image that you're projecting. So this is, let's say this is 1, there's a 2 on the side, and so on. And then all the stuff that is beyond this are going to be clipped out. So you're gonna cut this out. So for example, if you had a tree in the background here, this will just get cut out, and all you're left with is this image in this rectangle. And this gets projected outward here, and so on. Yeah, so likewise, the closer the object is, the bigger the projection. If something, let's say there's an object here, let's say there's a fly over here, or further back here, this gets projected but smaller sized over there. And then if you have something like just a big ball there, this gets projected and the entire screen will be covered in with the ball. So again, it shows you a 3D perspective from the viewpoint of where the location of the camera is. For example, if you're looking there for your eyes there, you're going to see just a big blob. So question 1, suppose the screen is represented by a rectangle in the YZ plane with vertices 0, plus or minus 400, 0, and 0, plus or minus 400, and 600, and the camera is located at 1000, 0, 0. And a line in the scene passes through the points 230, negative 285, 102, and 860, 105, 264. Then states at what point should L be clipped by the clipping planes. Alright, so let's take a look at the solution. So let's first graph out the information we are given using the amazing GeoGebra 3D graphing calculator. So what we could do is, if you go click the calculator, there's a link, you can play around with it. You can type polygon and then put in the 4 coordinates of the screen that we're given. So we have 0, plus or minus 400, and 0, and so on, and 0, 400, and then plus or minus 400 and 600. So 0, 400. And then we'll have 0, then 0, 400, 600, 0, negative 400, 600, then 0, negative 400, 0. So that's the screen. It will get something like this. So you get a rectangle if you just write polygon in there. So you get the screen, and you have also the camera here, the coordinates 1000, 0, 0. Then there's the line. You can just plug in both points, and it automatically calculates a vector equation of a line. But I'll do that manually. I just wanted to show it so we have a better grasp of what this question is asking. If we plug these in, these 2 points inside this, so line with 2 points, 20, 30, negative 285, 102, and 860, 105, 264. You're going to get a line in 3D like that. Then if you look at it this way, it looks something like this. And then the idea is, well, we want to know when to clip this out by projecting it on. So it's going to be clip it somewhere across there or here, depending on which plane it's going through. So let's just go over to here's the 3D graphing calculator. So there's the line, so you can hide it, or you can do that. So anyways, you see it in 3D. So it looks like this, and we're going to have to project a clipping plane and see where we're going to clip this from. So from here to there, and so on. So there's a screen. It's pretty epic 3D graphing calculator. All right, let's continue further. So here it is, looking at it from this view, and so on. But yeah, and we aren't necessarily going to clip from here. It depends on the 3D image of it. So this one's closer, so it should be clipped somewhere across there, and so on as we go through it like that, or something like that. Anyways, we'll continue further. So thus we need to determine the points on L which are beyond the projection to the screen, or actually more accurately, yeah, so what it actually is instead of beyond the projection to the screen, because again it's in 3D, so it's beyond the projected planes from the camera to the edges of the screen, because again we want to create a 3D 3D perspective, and hence they need to be clipped out, and this will look better now once we have these planes here, or on these clipping planes. So this means we need to determine the 4 clipping planes, which we can see below. Alright, and here's just the 4 clipping planes, which you can create in the GeoGebra, just putting a polygon from the camera to the vertices of the screen. And basically what we have is, I'll put the coordinates here. Instead of drawing it out, I was going to draw it out earlier manually, but it's going to take a bit too long, especially when we have a powerful graphing calculator like GeoGebra. Alright, so here's the point 1000 is at the camera. This vertex is going to be at, this is at 0, and then 400, and then the height is 600 in the the x-axis, the z-axis. It's going to be x, it's going to be your y, it's going to be your z. And then this point right here is going to be 0, 400, 0, and then this top part is going to be 0, negative 400, and then 600. And just for completeness, this last one is going to be 0, negative 400, and 0. And these are the 4 clipping planes. So basically we're going to have this one, I'm going to call this a right clipping plane. So the right clipping plane, like that. And then I'll call this then the top clipping plane. Then we're going to have the left, left C dot P. And then this is going to be left, and the top one, and then there's the CP, and then we have one at the bottom as well, like there. Let's put this here. Bottom. This is for completeness, but obviously the line's going to go through somewhere. If you saw it in 3D, it's going to go through somewhere like this. It's actually going to go through this top one. I'm going to clip it from there. Anyway, so that's what we have. So let's continue further. Alright, so now that we have this, so next we will need to determine the equations of the line and the clipping plane. So we're going to need the actual equations of all these and that line as well. So this line going through, so we need that, and then basically we set them equal and try to find the points where they intersect. And so recall the equations of lines and planes. Here's a screenshot from my earlier videos, equations of lines and planes, and I had the equations inside the screenshot, or inside the thumbnail, which is pretty epic. So there is r vector equals to of the line equals to the r naught vector. So this vector, this for all the points on the line, is equal to the r naught vector, the initial point, the point on the line, plus t times v. So t is the parameter, and v is the parallel vector. So this is parallel to this line. And then you can determine the vector equation of a line. And then for planes, you need a normal vector, the perpendicular one, so n, and then the dot product of the difference r minus r naught. So if you have a point like this, then subtracted by this one here. So basically this line right there, or this vector, So that vector, that difference, and then it's going to be dot product. You'll get, you set it equal to 0. That's the equation of a plane. So we'll get to that. So using the given 2 points of the line, we can thus determine the vector equation of the line and then the parametric equations of a line, or of the line. So then we'll get to that. And so let's go what we were given, and then basically we have to make it look like exactly this, because this is the automatic calculator just calculated the vector equation of a line. So we have the 2 points like here, 230, negative 285, 102, and 860, 105, 264. So let's just do all this. Let's just write this down manually for now. So r vector equals to r naught plus t v, and we have basically r naught, we'll choose a point on the line. So it's vector on the line, basically pointing to it. It's going to be 230, and make these triangle brackets for vector. 230, negative 285, and then this is going to be, I think 102. Let's just scroll back what it was. So 230, negative 285, and 102. Alright, so 102, like that. And then plus t, and then we need now we're going to need we need a parallel vector like that, so v, and we can determine that just by subtracting from this point to this point as a vector. So we can just write that out. So we'll just go as, we'll subtract, actually what I'll do, I'll write 860, I'll do it all in one go, just to save time. So 860 minus 230, is right here. And this is going to be this difference 0. This is going to be 3. It's going to be 6. And the reason I'm doing that is because this point right here. So we're going to take the difference between these as a vector. So 860 minus 230, 105 minus negative 285 is going to be plus. Then 264 minus 102. That's fascinating stuff. So the next one is going to be comma. And just do this instead of using a calculator. So 105 minus negative 285 is going to be plus. And then add those up. It's going to be 0. So this is going to be 1. It's going to be 9. It's going to be 3. It's 390. And lastly, the next point is going to be, well, we're going to subtract 102. And then the last point was 264. So 2, and then this is a 0. 6, and then 1. 162, like that. And just double check. So 105, 264. Yeah, so we have 105, 264, and then there's the 102, etc. All right. Yeah, so that's our vector equation of a line, but then we can get the parametric by just taking each individual one. So we'll just add these up. So what we'll have is the line is the equations x. The x coordinates are 230 plus t times 630 is 630. So x is equal to the x coordinates 230 in parametric form plus, I was right, 630t, like that. And then the y is going to be, I'll just, instead of putting a comma, just put a y like this. Y equals to negative 285 and then plus 390t. 90t. Let's make some, make it all to the left here. Yeah, just shifted it over. I'll put a comma. I like putting comma. My calculus book doesn't do it though. But anyway, so the next one's be z equals to 102 plus 162t. All right, and this is the equation of a line, like that. Yeah, these are the the parametric equations of a line. But you can see this here: 230, negative 285, 102, and then there's 630t. 390, 162, that's exactly what this calculator gave here. So 230, negative 285, and then there's 630, 390, 162 instead of, this is lambda instead of t. Alright, so now that we have the equation of a line there, the next setup is, well, the equation of the right clipping plane. So the right clipping plane can be determined by first obtaining its normal vector, which can be determined as the cross product of the line that extends from the camera, or from the camera to a corner, and the vertical line that connects that corner, or a vertical line connecting that corner. And basically, what it means is we want a vector from here to here, and then this vertical line. Use those as the point. So we'll draw it out. Basically, we're gonna have to draw a plane, draw a normal vector, and so on. Yeah. So let's say the camera is here. Let's say the camera is at 1000. 0 and 0, and now it's going to go extended. I'm going to put dash line like that, extends from here, and I will draw this is going to be the z axis, this is going to be, just to get our orientation correct, this is going to be the y, and this is going to be the x, like that. So this is going to be the x. Alright, so now let's draw the clipping plane. I'm going to draw it from here to the corner. Let's make it look nice. So I'm going to draw it like this to this edge, and then this is going to go straight down. So, line it up with this. Let's just keep it here. So that there's the one point. It's going to be dot, dot, dot all the way there, and there is the clipping plane of the right one. And this is going to be, and then let's just draw this for completeness. It's going to look something like this. And this is going to be dot, dot, dot. Extend it over there. Alright, so these are the points. I'm going to write this one as, this is the 0, 400, 600. And then we want to get the equation of a plane. So let's, what we'll do is, well, I'm going to erase this. And let's say our R naught vector is going to be just pointing to this. So this is going to be our R naught vector. Or actually, I'll draw that in red. So this is the R naught, like that. R naught. Alright, so that's the R naught, and then the R vector is just any point. Let's call this R, and it's going to be X, Y, Z. Any point on the plane, so it's a vector from there on the plane. So just put it somewhere in 3D space like that. And then the next setup is And now what I'll do is actually I'll keep this in, write this in blue actually now. Let's change the color into blue. Say dark blue. Alright, so we have that, and then the next setup is, well, we're going to need a normal vector. So, and I'll draw this normal vector like this. It's going to be n. It's going to be normal vector to the plane, which is the same as normal vector to these two lines, because they're on the plane. And now we can determine that normal vector by this line going across here. This is going to be our, I'll call this R1. And then we have a vector going from the vertical one down. It's going to be R2 like that. So, and basically the cross product of those two will get this normal vector like that. And we can determine these this R1 and R2 just by the difference when we subtract. I'll put this here. Let's go back to black. So then just put it like that, and this is this point, and basically when we subtract the two vectors, or the 2 points, and then we'll get a difference vector. This is going to be 0, 400, and 0, like that, the point. So let's determine R1. So R1 is going to be, well, this is just a difference, and it's a vector, so a difference, and we'll start from this point right here to this point. So it's just a difference, 0 minus 1000, like that. It's just indicated by the direction there. Yes, 0 minus 1000. And then the next one is the y-coordinates, 400 minus 0, and then 0 minus 0 minus 0. So this just equals to, so this part right here. So we're just subtracting each of these, so we get this R1 vector. So this equals to negative 1000, and then 400, then 0. And now, since this is pretty large right here, there's a bunch of zeros, we can just get rid of those, and all we care about is just a parallel vector to it. We don't want the exact, doesn't matter what the exact one is when we take the cross product. So what we'll do is factor out a negative 200. So negative 200, it's going to be out of there. It's going to be now negative 1000 divided by, negative 1000 divided by negative 200, that's just going to be positive 5. Then 400 divided by negative 200, that's just negative 2. 0, like that. So what we'll do is, well, we'll choose, I'm just going to choose the vector as, choose the R1 vector to be equal to, just to get rid of that negative 200, 5, negative 2, and 0. It's going to choose this, and that's it. Yeah, because, again, all that matters is the direction. We don't care about the magnitude of it. The cross product will be the same anyways. All right, so we have that. I'm just going to move this down. All right, now the next one is the R2 vectors, is the vertical one, so we'll go from this 0, 400, 0, subtracted by 0, 400, 600. All right, so let's see what we get. And now R2 equals to, this is going to be 0 minus 0, and then 400 minus 400, and then 0 minus 600. Let's just double check. So yeah, 0 minus 0, 400 minus 400, and then 0 minus 600. So this equals to 0, and then 0, the 400 cancels, and then it goes negative 600. And this just means, well, we'll just factor out the negative 600, just get it, just the direction. It's going to be 0, 0, and then, and then 1. So obviously we're just going to choose, let's put it like this, choose R2 equals to 0, 0, just simplifies the cross product, like that. Yeah, actually, no, the cross product will be different. It'll just be bigger or smaller if you get rid of the scale it. If you keep these 600s, it's just going to be longer or on the negative side, etc. But all that matters is we want the direction that's perpendicular to it, and just so the plane, when we find the equation of a plane, basically all the numbers get simplified and just be a parallel plane. But all the answers will be the exact same because we're just dealing with direction. We don't really care about the actual magnitude. So anyways, this all makes sense as we go along. So this is going to be now the n vector is equal to the cross product. So the normal vector cross product of R1 and R2. And let's do this. This equals to, yes, the cross product of these two. We're going to get this normal vector, and then after that we could throw that into our equation of a plane. So R minus R naught dot product with the n, and that equals 0. And so then this equals to, remember our cross product is going to be I, j, these are the unit vectors. or the principal vectors or whatever they're called. So I, j, k, and this is going to be now, the first one's going to be 5. Yeah, so it's much easier than dealing with like a 600, 1,000, etc. So 5, negative 2, 0, then 0, 0, 1. All right, so we have that. This equals to now, if you recall, so the first one we block out this one, cross it out like that, and then just multiply these two, and then subtract it by these two. So that's the first one. This is going to be negative 2 times by 1 minus 0. Like that, just going to be negative. And then I plus, the next one is going to be, do the same thing, but now it's a negative. The middle one's a negative, remember that. 5 times 1 is 5 minus 0. And then that's going to be j. Then plus the next one. Block this out. 5 times 0 minus negative 2 times 0. That's just going to be, well, 0 minus 0. This is going to be k. So this equals to negative 2i minus 5j plus 0k, and we can factor out the negative. So this equals to negative, and then I also get ready to write this in the triangle brackets format. So negative 2, 5, 0, like this, and then I'm just going to choose, because it doesn't matter which direction, top or down, as long as it's perpendicular, because we want the equation of a plane. This equals to, I'll just put it down here. So choose negative, a vector, the n vector equals 2, I get rid of that negative, 2, 5, 0. Alright, continuing further. So note that I chose the simplified vector, since all that is important is the direction of the vectors and not the magnitude or sign of it. And you could see that over here. I'm going to actually erase this and this. And you can see that here in the definition of the plane, for example, in the plane right here, yeah, we just have the vectors like this, r, and this generic, this generic r value right here, which it could be anywhere. It could be anywhere and any size. It doesn't specify the size. It could even be on the negative side here, so that the signs don't matter. And for example, this normal vector, it's just a normal vector. It could even be on the bottom side, and it could be long. It could be small. It does not matter what size it is or which direction, because it will still give you the plane. So the dot product will just equal to 0. It doesn't matter what the magnitude is. So hence why we could just use the simplest version of it. So now we can plug in the normal vector and a point on the plane into the vector equation of a plane to determine the linear equation of the first clipping plane, or the right clipping plane of the right. So we have the direction properly. So anyway, so we go n dot, and then r minus r naught equals 0, like that. All right, and then basically we'll put the normal vector is going to be 2, 5, 0 dot, and then this is going to be and then the difference between these two. I'm just going to put this all simplified. It's going to be the x minus the r naught. And remember, r naught, we just picked 1000, 0, because this is a point on the plane. It's actually a point on every clipping plane, because it's all intersecting that point. So it's going to be, I'm going to put a minus 1000, and then y minus 0, and then z minus 0, like that. This equals to 0, so the dot product, if you recall, is multiply each of the coordinates together. So 2 times x minus 2000. And then this is going to be, so 2 minuses inside, and then the next one is going to be 5 minus y minus 0, doesn't change anything. So 5y, and then plus z 0, that's going to be 0. Yeah, I'll just put a times z, 0 equals 0. So this vanishes, 0, and then move this over to the other side. We get a 2x plus 5y equals to 2000. So this is the equation of a plane. Alright, so now we got that. So now we need to determine if the line crosses the right clipping plane by plugging in our parametric equations of a line into the linear equation of a plane and solving for the parameter t. So that's the linear equation of a plane. This was the vector equation. There's a linear one. And let's plug it in. So let's put our line L for completeness. The coordinates, the parametric equations are 2x equals to 230 plus, or actually I'll just copy the whole thing down. Yeah, let's just scroll up here. Yeah, if we just go over here and just save time, I'm just going to copy this. Alright, so we copy that, and then go all the way down and just paste it here so we have it for reference. Like that. Alright, so we have the line, like that. I'm just going to remove that. So there's our line L, like this. Okay, move it up. Alright, so there's our line L, and then we have to plug these inside the equation of a plane. Alright, so that's the line L. I'll write P for plane, and then we're going to have 2. So 2x plus 5y, and then we're going to plug those inside. So 2, and then plug that inside, like this. Yeah, just plug this inside. This is going to be 230 plus 630t, and then plus 5y, and then put this inside. And then there's no z, so just ignore that. That's going to be negative 285 plus 390t equals to 0. And this equals 2000. 2000, not 0. Yeah, and there's no z values for the plane right here, so now we can just do some simplification and solving it. And so multiply this out. What I'm going to do is I'm going to multiply this, so 2 times 630, that's going to be 1260 t. And then multiply these ones in after, and then the next one's going to be plus, 5 times 390, that's going to be I'm just going to put a 0 for 5. Then 5 times 9 is 45. Carry the 4. 5 times 4. 5 times 3 is 15. It's going to be 1950 t. And then now we're going to put these together. So 2 times 230 is going to be 460. And then minus right here 5 times 285 times 5. Just do this all by manually, just for fun. So 5 times 5 is 25. Carry the 2. 5 times 8 is 40. Then add the 2, so 2. Carry the 4. 5 times 2 is 10. 14. So 1425. And then, this equals to 2000. So now we're going to have, now take the like terms, and we're going to have some, just some more arithmetic. I'm just going to put a space like this. So 1950 plus 1260. Add these up. It's going to be 0. 11, and this is going to be a 1. Carry the 1 to be 11. So 10, 2, and then there'll be 12 at 1. So 3, 2, 10 t. And then this equals 2, and then this one's going to be a big one. 2000 minus 4. We're going to move this over to the other side. Everything to the other side. So we're going to have a minus 460, and that's going to equal 2. Yeah, let's move things down. So 260 0 minus 0, 0, and this is going to be a 10, just using long subtraction. 10 minus 6 is 4, 9 minus 4 is 5, then we'll have a 2, 2540. Actually, no, this is a, when we take this 9 out, we have to cross it out and make a 1. So it's going to be a 1, 1540, and then we're going to have to, this one was a plus, so plus 1425. Alright, so we have that, and then the next one is going to be, now we just add these up. So 5, and then 4 times 2 is 6, and then this is going to be 9, and this will be 2. 2965. So then move this over, we get t is equal to 2965 over 32110. Yeah, 3210. That's an interesting number. So 321, and then plug it in the calculator, we get 0.9237 for t. Alright, and now just a quick calculation check. If you use Wolfram Alpha, just plug that in. So if you go 2 times 230 plus 630 t, and then plus 5 times negative 285 plus 390 t equals 2000, exactly what we had over here. So 2 times 230 plus 630 t, and this over here. Just plug that in and solve for t. You can just write solve for t, and it'll solve it, and it gives you t equals 593 divided by 642. And then if you plug in the calculator right here, if you divide this by 5, because ours was 5.65, and then just factor it out. Just factor out 5, and get 593, and use my built-in calculator. So you can go here, space, and space, and it goes there. And then likewise, if you calculate 2965 divided by 310, the built-in calculator in my OneNote is the same as 593. Yeah, so it's the same thing. So the calculation check this. So this is correct over here. Yeah, so thus plugging our value of the parameter t into the line, we obtain the point where it needs to be clipped on the first clipping plane, or at least where it's projected through. But it's actually clipped from the top plane as we continue in this problem. So it doesn't need to be clipped again from this line. So from the right, let's write this right. Yes, for completeness, put this here. So if you plug in the line, so 230 plus 630 times t, so replace it with 593 divided by 642, just simplified over there. And so we get these points. Press space. And the next one is going to be 75, etc. Again, built-in calculator. And the next one is for the line 251. Alright, so plotting all this out in the GeoGebra 3D graphing calculator, we can see where the lines get clipped. Alright, so here's the link. It's the same link. So what we have is there's a line. So here's another thing that you could do. You could just type in plane, and then put the polygon that we had from the vertices 0, the camera up to 0, 400, 0, and 0, 400, 600. It automatically solves the equation of a plane 2x plus 5y equals 2000, which is exactly what we had here. 2x plus 5y equals 2000. So absolutely remarkable stuff there. You can even do the cross product as well. So there's the plane. And if you plug in this point, so point P 811.92, 8.811.92, etc. is 75.251. 75 point, what was this? 0.23, I round up 24. Then 251.64. So it goes right here, and there's the plane crossing it across there. And here, let's go to the GeoGebra calculator. So let's see what we had, the clipping plane 1. So there's the plane, and there's the 3 points, and then there's the equation, and there's the point B, and there's the parameter t is 0.92. So you can just plug that in as well. And there it is. So it goes like that. And I also made the right clipping plane segment. I think clipping plane 2. Okay, so we had it like that, clipping plane 1. Yeah, you can also do the polygon version. So there it is. Yeah, so when you do the polygon, it actually goes above it. So it does not actually need to be clipped because it doesn't go through it. I mean, it needs to be clipped actually earlier from the top clipping plane, as I will show later. So that's pretty amazing stuff. All right, so now we got that part. Let's continue further. Let's make this smaller. All right, so simplify this. This is all giant. But yeah, so GeoGebra is pretty amazing stuff here. Alright, so now let's look at the next clipping plane. That's the top clipping plane. So let's follow the same procedure to find the top clipping plane and where the line intersects. So likewise, we'll draw from the camera 1000, 0, 0. And then what we'll do is this goes up like this to the top. It's at 0, 400, and then this is going to be 600. And then we'll go across it like this. Alright, and this part here is going to be at the 0, negative 400. And then 600. Alright, so we have that. And then let's just draw this in 3D. Put this down. And this is going to be all the way across. We're going to just erase that, add this dashed line for this part. This is going to be the Z. It's going to be the Y, just for completeness. It's going to be the X like that. This is the screen like this. Alright, and then yeah, the line's going to be across here. So basically we have this clipping plane, and we want the equation of this line. And again, this one's going to be pretty straightforward. Let's draw a blue one for, or dark blue for this part right here. So basically, we're going to have the normal vector. Normal vector. It's going to be normal to these. I'm going to call this one right here as R1. This is going to be R1, and then the next one I'm going to point it down this way. It's going to be R2, or actually, so that I just pointed this way. It's going to be R2. R2. And then we have the normal vectors parallel to both, it's going to be perpendicular to it and the plane, and so on. This is going to be our n. So we need to find R1 and R2, and this is going to be, obviously, our R. I'll draw this in red. All right, so this is going to be from here to here. This is going to be our R0, as always. And yeah, lastly, for completeness, I'll just finish this rest of the screen through the background, like this, and it goes like that. All right, so that's the screen, and there's the points, and now let's just determine these points. So R1 is equal to, so R1 is equal to, we'll subtract this one, this one from this, so we're going to go 0 minus 0, and then 400 minus 400, and then 600, 400 minus negative 400. So that'll be a plus. Yeah, so 400 minus negative 400 is a plus, and then 600 minus 600. And this is a square bracket. We're doing a vector, or a difference vector. This equals to 0, and then 800, and then we have a 0. And then factor out the 800. This equals to 800, and then this is going to be 0, 1, 0. So basically choose just the simplest one. So choose R1 equals to 0, 1, and 0. All right, and then the next one is R2. This equals 2. Yeah, this equals 2. We're going to go from 1,000 subtracted by these parts right here. Or actually, no, this part subtracted by 1,000 at the camera positions. So what we're going to get is a 0 minus 1,000. Then 400 minus 0, and then 600 minus 0. This equals to negative 1,000, and then 400, and then 600. So what's the common denominator in all this? And I'm going to go with, well, I want to get rid of this negative. Get rid of the negative in front, just because I want to. So that's going to be negative 200. And that's going to be now 500. It's going to be 5. So negative 1,000 divided by negative 200 is 5. And then this is it's going to be negative 2. So all the zeros cancel, and this will be 4 divided by 2, and add a negative. Yeah, take out that. And this is going to be, the next one's going to be negative 3. So choose, and get rid of that negative 2,000. So choose R2, a simplified version of it is going to be equal to negative 5, negative 2, and negative 3, like this. And write this better. All right. Absolutely perfect. All right, and now take the normal vector. So normal vector equals the cross product. R1 cross R2 equals 2, like this. And then again, the format j, and then k, then plug that in 0, 1, 0, and then 5, negative 2, negative 3, like that. All right, so this equals 2. Let's put it here, actually. Equals 2, cross this out. So what we get is 1 times negative 3, it's negative 3, minus this one's 0 times that's 0. And then the next one's minus, and then this is going to be 0 times negative 3 is 0, minus 0 times 5 is 0. And then this is j. And then the next one's going to be plus. Block this out. So 0 times negative 2 is 0, minus 5. Okay, like that. All right. All right, so now that we get is, well, equals to negative 3i minus 5k. And let's factor out the negative and write this in the other format with the triangle bracket. So negative 3, 0, 5. And then basically choose n, just a simplified version of it, get rid of the negative, n equals to 3, 0, and 5. Like that. And then likewise, find the equation of a plane. So I'll write this P for plane. And this is the vector equation, n dot product r minus r naught. And r naught's always going to be the camera position. So this equals 2 negative, this is going to be 305 dot x minus 1000. And then the other one's going to be 0, 0. So yeah, I mean, not 0, 0. Y minus 0 is for completeness, write all. Y minus 0, and then z minus 0, because r naught is 1000, 0, 0, equals to 0. All right, multiply this out. This equals 2, 3x. Yeah, so 3x, and then I'll just put this in for completeness, 3x minus 3000. I mean, yeah, 3000 like that. And then here we have the 0, just everything, the y is gone. So now the next one is 5z equals to 0. So this equals 2, move this over to the other side. We get a 3x plus 5z equals to 3000. That's the equation of the plane. All right, and now the next one is, well, we got to plug in our line inside. So I'll just put, I already had it copied and pasted, so we didn't change anything. So I'll just move this like this. So there's the line L, and I'll write plugging in L. So plug that in, so we get so the P, the equation of the plane, with the line inside, we get 3, 230 plus 630t, like this. And then plus, this is y is gone, plus the next one is z. 102 plus 162. T equals to 3000. Alright, so we have this. And yeah, let's put an arrow just for completeness. This part goes into here. And then this goes into here. And then the y, there's none. Alright, so we have that. The next one is, we'll just multiply it all out, and then yeah, just do some manual calculations again, and eventually I'll just do it all with the calculator. But anyways, so we'll have 3 times 630. I'll do the t's first. So yeah, 6 times 230. 3 times 630. So 3 times 0 is 0. Let's put 0t, and then 3 times 9. 3 times 6 is 18. So 189t. And then 5 times 162, that's going to be, yeah, so 5 times 2 is 10. So 0, t, carry the 1. 5 times 6 is 30, add the 1 is 1, carry the 3. 5 times 1 is 5, plus 3 is 8. So 8, 10, like that. Yeah, that's 8, 10, t, so this would be plus. The t better. And then the next one is, now we put these like terms inside. So these 3 times 2, 30. So 3 times 0 is 0. 3 times 3 is 9. 3 times 2 is 6. 690. And then the next one is plus this 510. So 5 times, I mean, it's 5 times 102, not 5 times. So 5 times 102. So 5 times 2 is 10. Add the 1. 5 times 0 is 1. I mean, is 0. Add the 1. And then 5 times 510. Like that equals to 3000. Alright, so now let's put these all together. Let's do this one because it's longer, so we'll get a 3000 minus 690, because we'll move this over to the other side. 690, like that, 690, this equals 0, this makes it 10, carry the 9, or lower 1, just using a long subtraction. 10 minus 9 is 1, 9 minus 6 is 3, 3 minus 3 is yeah, so 3. Like, actually, no, if we cross out this to make a 9, this has to be a 2. So 2, 3, 10. And the next one is, now we're going to subtract by 510. Alright, this goes to 0. This is 0. 3 becomes 13. This becomes 11. So this is going to be 13 minus 5 is 8. And this is going to be, I mean, not 11, 1. So 1. So 1, 800, like that. Yeah, so that's 800. I'll put an equal sign to make it all match up. With this side is going to be t, and then this is going to be, add these up, 1890 plus 810, and lower this and move it, and put a plus sign. This is going to be 0, this is 0, add a 1, 8, 16, 17, add a 1, 2, 7, 0, 0. Alright, so t equals to 800 over 2700, and plug this into the calculator. Or actually, instead of that, we could just simplify it further. Just cross out the zeros. This equals to 18 over 27, and then what we could do is, what we could do now is, well, this is 18. This is all these are factors of 9. So what we'll do is divided by 9 on both sides. So we get a 2. And then over 3. Yeah, so that's the answer. 2 over 3 is the parameter t. Alright, so now continuing further, we could do a calculation check. So again, using Wolfram alpha, and just plug that inside. So solve for t, and then we'll have 3 times 230 plus 630t, plus 5 times 102 plus 162 equals 3000, and solve for t. And again, that's the same equation here. And then solve that, and it solves t equals 2 over 3, which is remarkable. And plugging in our value for t, just plug it in right here in the built-in built-in OneNote calculator. 3 equals 650, and then -25, and then 210 here for the z. And then graphing this out in GeoGebra, we get this over here, and there's the line. So there it is. If you plug in t2 here, or the parameter t equals 2 over 3, plug that inside here. For the point A, this is the equation of the line there, the parametric equations, and there's the again the clipping plane. Plug these values in, it automatically gets 3x plus 5z equals 3000. So it gets 3x plus 5z equals 3000. Absolutely remarkable. And then it shows here. So notice here the line crosses here like that. And let's just graph this out ourselves. So that was the triangle. We already saw that it goes over it, so it doesn't actually clip it. It gets clipped before then. So let's go over clipping plane 2, or that was that line. So let's see the clipping plane here. So there's the plane that we just graphed, and there's a triangle that goes straight through that triangle there, that plane, and then the point A is this one here, and there's a point A. So we just need to clip it over here, and it automatically clips at B. So we don't need to clip at B, we just clip at A there. Epic stuff here. Alright, so note that clipping at the top plane A, or at the top plane with this A point, means we don't need to clip again at the right clipping plane B. So we don't need to clip there. Epic stuff. So now, let's look at the equation of the left clipping plane. Alright, so by symmetry, the left clipping plane is the same as the right clipping plane, but every y is replaced by negative y. Alright, and we can see that here. So let's say we had, there's their camera. So our camera goes to here. So this point right here, I'll put it here because it's going to be the same for all of ours. 0, 0, and this goes to this point. This is going to be, or actually make it even closer just to fit everything in. This point's going to be 0, 400, 0, and then it goes up like this. Goes up like this, and then this point, this is the right clipping plane, like that. And this point is at 0, 400, 600. And this is our right clipping plane. Alright. So right clipping plane. I'll put it here, plane. And I'll just underline this, and this, recall the equation of this. This was 2x plus 5y equals to 2000. And let's just scroll up to double check that. And that was right over here. So where's the clipping plane right here? So you have 2x plus 5y equals 2000. And that is this one right here. So that is our right clipping plane. So that's the right clipping plane. And now, for completeness, so let's just draw the other side now. This goes like this, dot, dot, dot. And then this goes all the way across like this. Let's draw the plane. This goes down, this goes dot, 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 like that. Alright? And this goes across like this. There's the plane like that, and so on. And this is going to be our Z. This is our Y, this is our X, like that. Alright. Yeah, so then if you look at it, the formulas were all created with everything the same, except the Y is flipped. So it's going to be 0, and then it's going to be negative 400, 600. This one's going to be 0, negative 400, 0. Yeah, so then this is the left clipping plane. Clipping plane. Underline it. So then we just replace the y with negative. It turns out to be exactly correct. Here I just made everything a bit smaller to fit in. So this is going to be 2x plus 5 negative y. So we just put the exact same thing, put a negative y equals to 2000. So in other words, our left clipping plane is going to be 2x plus, negative, 5y. So for every point of every y coordinate, we flip it over to the other side. 5y equals to 2000. So we saved a bunch of time by symmetry instead of having to do cross products and so on. All right, so now that we have that, so the next setup is just, well, we'll just plug in our L. So plugging in L, the line, we get, and let's just, I have this still copied and pasted. I have it copied it from the line earlier. Let's remove this box. And there's a line, L, like that. So shift this up higher. Alright, so we have, and now let's plug that in. So we get plane P, 2x, x is 230, plus 630, and then T, so T like this. And then this is going to be negative, and then the y, this is going to be 5, and then put that inside, negative 285 plus 390 T equals to 2000, Alright, so now the next setup is, let's do the same thing, multiply the common denominator, the common setup, the T's first. It's 2 times 630, 2 times 0 is 0, let's put a T there. 2 times 3 is 6, and 2 times 6 is 12. So 1260, like that. And then the next one is, it's going to be negative 5 times 390. So 5 times 0 is 0, T. 5 times 9 is 45. Put a 9, carry the 4. 5 times 3 is 15, this is 19. 1950, like that. Alright, and now the next setup is multiplied by the ones without the t, so 2 times 230, that's just going to be, well, that's 460. Then negative 5 times negative 285, that's going to be plus, 5 times 5 is 25, carry the 2, 5 times 8 is 40, so 2, and then, so we have a 2, then 5 times, so 5 times 8 is, it's 40, carry the 2, add the 2, but carry the 4. So 5 times 2 is 10, 14. So 14 to 5, like that. This equals to 2000. Alright, so now the next setup is we could just do the right side first. Just again, do it all by hand, just for fun. Not everything needs a calculator. So it's 0, so this is going to be 10, put a 9. And that means we also have to make this a 9 as well. And this becomes a 1. Because whenever you take 1, you have to subtract 1 from the next one. So 10 times 0, this is just going to be 0. And actually, since 0 minus 0, we're not actually subtracting by a bigger one. So this is going to be the 10. So this one has nothing, no issue with that. So 10 minus 6 is 4. Then 9 minus 4 is 5. And then 1 minus 0 is 1. So we have a 154, and then the next setup is minus the 1425. Like that. This is going to be a 10. This is going to be a 3. Whoops. This is going to be a 3. This is a subtraction. It's 3 minus 2. This is going to be 5. 1, 1, 1. So 1, 1. 5. Actually, no, we forgot the 1 here. This is 1425, not 425. Minus 1 is 0. So yes, 115. Like that. So I'll put an equal sign to line it up. This is going to be, and put a T. This is going to be right here, 1260 minus 1950. But actually what this means is because this is we're subtracting by a bigger number there, what we'll do is I'm just going to put a negative like this. Then we're going to have a 1950 minus. It's a minus, and I put a because then we have to the way subtraction works is because you can't just subtract a bigger number, so you have to go put the bigger number, subtract by the smaller, and put a negative. So we have this negative side like that. Yeah, because we're subtracting by a bigger number. So we'll have it like this, the difference, and then put a negative. So this equals negative. This would be 0 minus 0 is 0. This can be 15. This brings it down 8. So 15 minus 6 is 9. 8 minus 2 is 6. That's 0. 690, negative 690. T equals 115. So this means T is equal to 115 over 690, or negative. So put the negative. So block it off, move it over, put a negative, and this equals 2, or actually I'll just leave it. Or actually when you plug in the calculator, it actually simplifies it over to negative 1 over 6. And it will do a double check of that. So that's epic stuff there. Alright, so let's do a calculation check as always with Wolfram Alpha. So solve for T, and then 2 times 230 plus 630, and then have a minus right here, 5. Etc. equals to 2000. Solve it, you get T equals negative 1 over 6. So yeah, 1 over 6 equals to 0.1667. Then 115 divided by 690 equals to 0.1667. So it's correct. And so you go over here with the calculator. You can go equals, and then divided by 115 divided by 5 is 23. And then you can go this right here, 690 divided by 5. This equals to 138. Then 138 is 23 is a factor of 138. So 138 divided by 23 equals 6. So yeah, so 1 over 6. Epic stuff here. Yeah, because I didn't want to do that here because it just seems a bit out there. So you divide by 5 and just simplify it further. Yeah, so you could, but I just want to use a calculator there. It's just a bit out there. Anyways. Now the next setup here is you can even try it out 5 times. So put these factors back in. So 5 times 23 divided by 5 times 23 times 6, because then these will all cancel. Just left with 1 over 6 equals 0.1667. Anyway, so plugging in our value of T into the line, into the equation of a line, into the parametric equations of the line, we get 230 plus 630 the times negative 1 over 6 equals 125, etc. And so on, then you get this negative 350, 75. And then graphing this out, we get in GeoGebra, and here again, put the plane equation, put this, just put this all in, and it automatically solves it. And exactly what we had, 2x negative 5y equals 2000. Then put the t as negative 1 over 6, put that in the parametric equation of a line as a point. And it gets 125, negative 350, 75. 125, negative 350, 75. And then you graph it out, it crosses right over there. So epic stuff there. And let's just go and graph this out. So we graph this out, and so that's that top part. And let's go to clipping plane 3. So there's the plane. So notice the giant part. But let's draw the clipping 4. What is this one? This is the, I think that, yeah, there's the point there, goes right across there, but let's draw that triangle there. Clipping plane 2, clipping plane, and then I had it here, 3. Yeah. So you can, those are the full planes, but then there's that triangle, the polygon, right on that spot. There's epic stuff. So there's the part we need to clip. So basically we need to clip from C and A. And the reason you don't clip at the B, because it's you're looking at it in 3D, so this one would be viewing it as going up overhead above you. So hence why you want to get that 3D perspective onto the screen. So epic stuff. All right, so equation of the bottom plane now. All right, so now let's go further and look at the equation of the bottom clipping plane. Equation of the bottom clipping plane. So the bottom clipping plane is just the XY plane, which is just a set of all values where z equals to 0. So yeah, because if you graph this all out, so here's our camera. Camera's at 1000, 0, and 0. So then the clipping plane is going to be, well, 2 points. This is going to go, let's say we have, here's the z, y, x, like this. This reaches all the way up to here. And then our plane is going to be, our screen. Let's move this down. Let's move this down here. So there's our screen. So screens like this, and there's our screen. Yeah, so there's a screen, and so the bottom points are just going to be from here 0, 400, and 0, and this one's going to be 0, negative 400, 0, like that. Yeah, so the clipping plane is going to be bottom here to here, but this is just parallel with just the overall plane like this. Well, yeah, just the overall plane, and the perpendicular line is just going to be straight vertical like that. And this is it's going vertical up, like that. So so that the normal vector is just pointing upwards, and that and this is parallel to, this is perpendicular to the plane where it's all these values, and all these values are just at z equals 0. So this is our plane. So yeah, so this point here is on z equals 0. This point here is on z equals 0. This point here is on z equals 0. So they're all on z equals to 0 plane. So that's the plane. Like that. So plugging in L. So I'll write plugging in L. And again, I have it still copied. And whoops, I don't know why it went all the way there. Let's move it back here. Let's move it and move it here. Alright, so we plug in L, and I'll move this upwards. So we plug in L, remove this thingy, put the T up top, and then this is our plane now, is z equals 0, and plug that inside. Well, z equals 2, that's just this part right here. Or we replace z now with this 102 plus 162, T equals 0. Put the bracket just so looks like, yeah, we're plugging that in. So then move this over, we get T is equal to a negative 102 over 162, like that. And here, let's just divide this out by 2. So 51 times 2 is 102. So 51, and the bottom one is going to be 81. So this is a quick simplification. Alright, so now if we just plugging in our value of T into the line, we get right here, so negative, plug in the parameter T as negative 51 over 81. So we get these values here, equals negative 166.66, etc. And then you have this negative 5.3, and this other one right here all goes to 0, as it should. So that was a good double check, because it should be on the plane of z equals 0, and it is. So if you put the clipping plane 4 as these the coordinates, and you just auto-calculate z equals 0, if you plug in T as negative 51 over 81, you get, and then plug that inside, you get this here as well. There's 0 z. So it crosses here, and it goes beyond, so the bottom clipping plane clips it here, but it's beyond that projection, so it doesn't need to be clipped. So all that matters is this and this. And then everything else is beyond it. So here's a summary. So the line passes through only the two clipping planes, only through two clipping planes. The top one at point A, and the bottom one at, and one of the sides. And one of the sides at point C, or the right side. I'll just say, and here's put, and the right side at point C, like that. Epic stuff here. Let's go to the, graph it all out. So that is all that stuff. And what I'll do is I'm going to remove, actually we'll keep that. Let's just go to the bottom. I think the bottom clipping plane is z equals 0. Like that, and this point D. So it goes all the way behind it. Yeah, you see it better like that. Yes, epic stuff here. So all that matters is this, the left and the top. And this is not the right side, the left side. So left side at point C. So that was the left side viewing it from the camera. And epic stuff there. Alright, so thus the line gets clipped at the points. And then on the top clipping plane at the point 650, negative 250, and 210. And on the left clipping plane at the point 125, negative 350, 75. And let's just check we got those correct. This going over here. And those points are, where's the points? Yeah, so there's a point A, 650, negative 25, 210. Then point C, 125, negative 350, 75. And that is actually what we get. 125, negative 350, 75, and 650, negative 250, 210. So epic stuff.